Hey, my name is Will. Welcome to a new video on TroubleTelevision. Last time we looked into how to build a clicker game. I thought I made a second video regarding that. Today I want to talk a little bit about the gameplay, and this is not something I can just glance over, so we need to get a little bit into the code. And I'm also gonna explain a little bit about the autoplay we have. Okay, so the current game we have is basically that we have now like a little bit improved interface, a little bit improved like handling of everything, balancing. I changed a lot actually. We have now like the whole autoplay section has like three options. We have like energy management, money management, and the gen boost, which is relevant if you come to the higher like conversion rates from coins to money. I added the store save game handling for export import just so you have like the possibility to actually save your save game. Like if you have like a certain state you don't want to lose, you can just export it and import it somewhere else. Also, since the storage is like we are using just local store because it was technically just like a POC, you might wanna yeah, back up your save game if you really like want to keep it just in case the browser like deletes it because of storage issues or something. And the last thing I added was actually like a coupon section because I was thinking of like the possibility to grant like certain things in the game based on yeah, coupons basically, so to make it more interesting for people to get into the game. Okay, so when we talk about save games, we technically talk about three stages. In our case, even four, but let's talk about the three stages at hand. The first one is we need to save the game. The second is we need to reload or need to have the possibility to basically like fetch the game state. And the third one is actually that we have like a periodical sync where we evaluate how much time, for example, has passed between the last like played state and the current state you're entering the game again. Storing the save game is quite easy, because we use like local storage. We just use like two separate functions. We use for saving the save game set item and for retrieving the save game get item. When you save the save game, I would advise that you actually store like the date you saved it as well. This makes it easier like for the syncing, but it is also quite nice to have like a pinpointing where you can say, all right, I know that when this data basically was created. So if you have like, for example, like in the future, maybe a possibility to actually upload all your save games, you can like trace down basically where a certain state was happening or what a certain state was at a certain point of time. We save everything that really needs to be saved. So we save the coinage, of course, the cache, the energy, the CPU level, RAM level, GPU level, and the whole leveling regarding the autoplay. Also, since we have now prestige levels, which are like the currency in the store, we also save like the next rate that you would get when you restart the game, and we also store the amount of prestige levels you already unlocked. We store also like the picked color because since we have now color schemes in the game, maybe try it out so you can see what this is all about. We also need to save the color, of course, because else you would have like the problem that when you restart the game or just reload the page, basically, you would get the default color, not the color you actually picked. The purchases we need to store as well, because of course, if you bought something in the store, you should have it like in every reload of the game and not need to buy it again, because technically this would be a wasting of the prestige levels you already gained. And the last thing that is also like regarding the autoplay, this is the rate boost level. We also need to save, of course, because if you purchase it, you should keep it in the game. We do all of this, like we create like a a regular like JavaScript object. I JSON stringified and also base 64 encrypted. The reason for that is it could be in some cases or like in the future maybe that I have like special things that are written like in the strings or whatever, and I don't really want to like get into um like problems where, for example, like a charset or something breaks the save game. And also this adds a little bit of obfuscation to like the save game. So if you know where to find it, you don't really like can look easily into it. You really need to do something to it. Okay, so regarding loading the save game, we need to have like a couple of things in mind. First is what happens if the game, like the save game breaks. We need to consider that. And we also need to consider what if the save game wasn't like there to begin with. Both of those cases are handled basically in the first 5 lines. So we say, all right, we save game by default is an object. We say load the save game from the local storage or use the provided one. The reason for this is that we actually, or that I implemented like an import. So I'm using the same process for like if you export a save game, of course, you just show like the item that is stored. If you import it, you need to process the save game as well. So I use the same method for importing as I use like for fetching it from local storage. So I use like this. I decode the base 64, I JSON parse it, of course, so I get the object. If there something happens during this step, we actually like just print out an error, and then we have like the assignment again. So technically everything we did in saving, where we stored everything, we do like the opposite. We say, all right, if you have a save game, get me the coins and put it in the game state, cache, CPU level, and all other stuff. If anything of this like fails, that's why we have like the Elvis selector here. This means if save game is not available, it won't do coins. So in this case, if like we do this selector, we actually get like an undefined state. And if we do undefined, we can do like the shorthand for do else. And in this case, we say, all right, then set it to 0 if you can't load the save game. This case actually fixes a lot of issues if there's really like an error. Like if for example, the save game doesn't exist, if there's something broken in the save game or whatever, you will get like the default state, which is 0, or like the default color, for example, for the pick color, or like the default purchases, so you can actually select the default color. And afterwards, we return the last saved or the current date, of course, because we need the default here as well for the further handling. So this is saving and loading the game. The next thing we need to do is the syncing. And you have a couple of options when you do syncing. I picked, for my mind, the easiest one, which is I load the save game, check what the time difference is, and then I just let a callback run, because I have like for coin generation, for energy decrease, for autoplay, for everything. I have technically a certain rate I have like in the interval, right? So I can just do like a callback where I check if the tick, because I run all through all the ticks that I missed basically since the last time. If any of them matches, I basically just execute the function. So let's see this in action. I have here a game sync, all right. I do this sync function. As you can see in the signature, I just accept like a callback. I load in this function the save game. I calculate the difference, and then I let the difference run through, which is like all the ticks, and I call like the callback that is provided with every tick. In this case, I say then, all right, if the tick coincidentally matches the gain rate, execute gain, which is like the coin generation. If if it coincides with like the use rate, execute the use, so the energy decrease, autoplay, and then increase prestige, of course. And this is all done actually on first updated, so when the game is loading, basically. And the reason for that is that I want to have like on a reload, like if you access the page again, that all the missed stuff is run through before you actually start the game and make it playable. This sometimes takes a time, especially if you played a long time, but this is like the most stable thing I could think of to actually make it happen. If any of you maybe have like a good idea how to make it easier, then yeah, let me know. I also have like this is like this is the call basically for the initial sync. Second thing I actually implemented was that I also do this on the gain rate interval. The reason for that is there is sometimes a hiccup in browsers that, for example, JavaScript is stopped, but the page technically isn't reloaded. So it would make sense to have like a rate, and gain rate is like the fastest thing. I like the fastest interval I have actually in the game. So I have like here the same thing where I basically say, all right, if there is like a difference between the current date and the last date I have, then there should be actually like a game sync. And I do it a little bit like gracefully because I don't do it like for every um yeah, every 220 milliseconds that actually the rate runs, but I say, all right, if there is like a difference of like half a second, please do a game sync as well. This is like just in case the browser like stops the execution. And I think I also do the same thing for use and autoplay, just because I don't really know when the browser stops basically JavaScript running, which will be the first rate that is called. So I just implemented it on every rate. And yeah, so we sync like a lot to make it like really stable, which stuff we have. Okay, as I mentioned, there's a fourth point we actually need to consider for this game. And the reason for that is that I wanted this idle game to have like the possibility that it plays like a roguelike. So that you technically restart over and over and over again, and you increase that basically your gameplay of the next run. What we need to make it like a roguelike, we need to have like a reset thingy where we can reset everything, and in our case, basically set the prestige fragments you collected during this run to the current prestige fragments you have. So you have like the possibility to increase your generation rate, to have the possibility to um yeah, basically convert more coins, because I also implemented this there. Yeah, so our fourth like pillar we need is like a reset, because as soon as we reset, we will have like in the next run, it will be saved. So we get like the new state also in the save game. And so we just need to make sure that basically we actually update the state in the game, not in the save game, because the save game will be handled automatically by like our interval functions. Okay, so far so good for like the save game. This is technically everything I have to tell about that. If there are any questions, let me know in the comments. And maybe do like a quick excursus as well in the autoplay section. As I already mentioned a couple of times, right, we have like the gain, we have the use and the autoplay function that are executed like periodically to credit the new coinage, to decrease the energy that you actually like use, and also to do something which I call autoplay, but I guess it is also called like the idle part of the game. I'm not sure. Where it's about that you have like certain management types, so you don't have to be on the game like all the time. You can like play it or reset it like in the morning, come back in the afternoon, and have like a state where you can just like pick up where you left off. So that's why I actually implemented the auto management, or the autoplay, where I say, all right, we have like two crucial things. The coinage itself can't buy you shit in this game. So you need to convert it to money, or cash in our case. And you also need to buy energy, so your components actually have the possibility to run, just to make it more real, basically. So we need to have like an autoplay for those two like segments. We need to have like something where the energy is continuously created or generated or bought, and we need to have something where the coins are actually exchanged, so you can actually buy energy. Um, yeah, and have like a playable state when you come back like later in the day or something. And this is actually quite simple to do. So what I've done basically is I implemented like a tier system where I say, all right, I have certain levels because this allows me to in the future uh, allow, for example, a fourth level. Let's look into it in the game. Like we have here, for example, the level 1, we have the level 2, the level 3 for like the energy and also for the cash thing. And we use the singular number, like the 1, 2, 3, we use to calculate actually what the price is for the element itself. And we also calculate what the rate is that we actually apply. And I also implemented it the way that we actually use like the prestige fragment or prestige coin or prestige level or how you want to call it, and like thing actually factors into how much you generate or convert or whatever. Like on level 1 for energy generation, for example, you start with 3.5k, I think, for energy creation. Then you get up to 50, I think, and then 90 is like the max. And for coinage, you start with 10. In our case, we already have like the modification through like the prestige fragments, but you would start with 10. The second one, I think, is like 200 or 100 or something, and the last one is 500. Yeah, I think that's it for today. I might do a third video regarding like how balancing of this game actually worked or what I did and how I implemented the store. This might be interesting as well. But yeah, thanks for watching and see you next time.